starting with the chapter Electromagnetic Induction. Electromagnetic induction, it is a phenomena of producing EMF in a conductor by changing some magnetic flux in the coil. This is called as the electromagnetic induction. Basically, firstly, it was Danish physicist, it was Oriested who discovered that magnetic field can be produced due to an electric current. So after that discovery, the scientists started thinking that can the vice versa happen, that whether it is possible to produce electric current using a magnetic field. So the answer was yes, and the phenomena in which EMF is produced in a conductor by changing some magnetic field is called as an electromagnetic induction. So we have certain laws for that, that is for the laws of the electromagnetic induction. So for instance, suppose we have a coil, okay, with n numbers of turns, and in that coil, if we bring a magnet nearby that coil, okay, and somehow that magnet is having a magnetic field, okay, and if that magnet is brought close to the towards the coil, a EMF is induced inside this coil, okay, and that EMF will depend on certain factors that is shown by this laws, that is the Faraday's law. First law says that the change in the magnetic field, the EMF is induced. That is, in order to produce the EMF, the magnetic flux should change. That is, the area to the amount of magnetic field coming out from a certain area, that should change simultaneously in order to produce the EMF. Okay. So there has to be a to and fro motion of this magnet towards and away from the coil in order to induce the EMF. Also, second law states that the magnitude of the induced EMF is directly proportional to the rate of change of the magnetic flux through the coil. Means the faster the magnet will move to and fro away from this coil, the current produced will be higher and higher. Next, the third law is the Lenz's law. It states that E is equals to minus d phi by dt, where phi is the magnetic flux which is going to change with respect to time, and the direction of the induced EMF or the current or the in a conductor is opposite to that of the change in the magnetic flux. So that's why we have a minus sign, and this is the induced EMF which is given by E. Okay. Next phenomena which we are going to understand, it is based on the same principle of electromagnetic induction, where we are studying self-induction and mutual induction. Self-induction is this. We have a circuit here where we have a inductance, and it is connected to a battery and a tap key K. When the current flows through this coil, the magnetic field and the magnetic flux linked with the coil changes. Okay. The change happens because of the change in the current. Okay, whenever the current flowing through this coil changes, the magnetic field and the magnetic flux which are linked with this coil, they also changes, and because of this an EMF is induced inside this coil, and this phenomena is called to be as self-induction. So here we again use the Lenz's law, E equals to minus d phi by dt, where we have used a constant for the directly proportionality. We use a constant L. L is called as the coefficient of self-inductance, and that coefficient of self-inductance we can get the formula to be L equals to E di by dt. Okay. Next concept is about the mutual induction. In this circuit, we have two different connections where we have two coils which are kept close to each other, and the current in one of the coil is changing and the EMF is induced in the second coil. So we have two coils out here, primary coil and the secondary coil. The current will be changed in this primary coil and the EMF will be induced in the secondary coil, and this process is called as the mutual inductions. So what happens is, whenever the key is on, the current starts flowing in the primary coil, and that current, due to the change in the current and EMF is induced, that EMF induction certainly takes place in the secondary coil. As a result, here there is a galvanometer which shows some amount of current out here. Okay. So again, we the magnetic flux which is 5s by the secondary coil, linked with the secondary coil, it depends upon the current in the primary coil. It directly depends on the current in the primary coil flowing to the primary coil at that instant. So we have 5s is equals to Ip. On 5s, that proportionality, we use a constant called as M, that is called as the coefficient of mutual induction. Okay, and that coefficient of mutual induction we can get the value to be m equals to es upon dip upon dt, where es is the induction produced in the secondary coil upon ip upon t. So next we have a transformer which works on the same principle as of the electromagnetic induction and in that mutual induction. So whenever the magnetic flux linked with the coil changes and EMF is induced in the neighboring coil, the same principle happens to be working with this transformer. So transformers are of two types. There are step up transformers and step down transformers. So basically it is nothing but two coils, which is called as a primary coil and a secondary coil. So the step up and the step down depends upon the number of turns of coilings which has been done to the primary as well as to the secondary coil. So now each of this coil is insulated with winds of soft iron core, and then when an alternating current from here it goes into the primary coil, the coil it goes on the current is AC current, so it goes on changing, hence the magnetic flux through the core also changes out here, and hence as a result of this change, an EMF is induced in the secondary coil, and this EMF induced in the secondary coil will depend upon the number of turns of the primary coil, number of turns of woundings which we have done on the primary as well as on the secondary coil. So here again, using the same mutual induction principle, the the voltage induced in the primary coil depends upon the magnetic flux in the primary coil upon T. There we have a constant, that constant is N, that N is called as the number of turns which we are using in the primary coil. Again, the voltage induced in the secondary coil depends upon the flux in the secondary coil. For that we use a constant called as N, that is also the number of turns of the secondary coil. Okay, using the first and the second equation we get that ES upon EP is equals to NS upon NP. This is called as the transformers equation, where NS upon NP is called as the turns ratio. Okay, this is called as the turns ratio, that is the number of turnings which we have done to both the primary as well as the secondary coil. On this basis we define whether a transformer is a step up or a step down. If NS is greater than NP, that is the number of turns with the secondary coil is greater then the number of turns in the primary coil, then it is called as a step up transformer. This is called as a step up transformer. In this type of transformer, the current in the secondary coil is less here, and that of the current in the primary coil is more. Okay, so we have current in the secondary coil is less than the current in the primary coil. Next thing, we have the step down transformer, totally different, that is NS should be lesser than the NP, that is the number of turns in the secondary coils are less and the number of turns in the primary coil are more. As a result, the current in the secondary coil, that is current in the secondary coil is greater than the current in the primary coil. Okay, so this is called as the step down transformer. Okay, step down transformer, and this is the stepped up transformer and the stepped down transformer. Okay, so the next concept which we have is a alternating current. Okay, so here then in this alternating current we have a circuit with a connected with a resistor and an alternating EMF which is given. The value for the EMF is E equals to E naught sine omega t, which is E naught is the peak value and R is the resistance. So at after a particular time, the current I starts flowing through this entire circuit, and which is given by this Ohm's law, where we have V equals to IR. Instead we can have E equals to IR. Okay, similar way I equals to E upon R. So next, using this equation E equals to E naught sine omega t, we can also have I equals to E naught sine omega t upon R. Okay, so there are values where your current starts increasing and it reaches a peak value which is called as the I naught. Also your voltage goes on increasing and it reaches a peak value called as E naught. Okay, so substituting those values we get the final equation to be I equals to I naught sine omega t. So if we draw a graph of that I against the time or theta against omega t, we get something this I against the time t. The maximum value of the current, that is the current, it is going up to the maximum value, it is called as the peak value, or it is denoted by I naught. Okay, and the current in the resistor is positive during the half cycle and it is negative during the next half cycle. Therefore the current generated in the resistor of the circuit R is an alternating current.